The last section of Chapter 8 is just going to discuss some of the examples that we have of oxidation and reduction in the real world. It starts out by talking about how oxygen is very reactive, which is kind of the understatement of the year. We have things such as hydrogen peroxide, which can be used as an antiseptic to kill bacteria and infections. Oxygen in the form of hypochlorite ions is used to bleach clothes. Fuel burns much quicker in pure liquid oxygen than in air, so this oxidation reaction is what helped SpaceX blast into orbit. And these are all basic ways that oxygen can be used in an oxidation reaction. Another way you might not have heard about oxygen is through ozone, where oxygen gas is required for human life. Obviously, we all breathe it, but once it reacts to form ozone, it's even more reactive. It's in fact even more reactive than the chlorine you put in your pool. In fact, you can use ozone in hot tubs instead of chlorine as a disinfectant. But in contrast to the benefits, ozone can be harmful. Ozone is harmful to animals and humans as a pollutant that harms our breathing. It's harmful to plant life. It reacts and just destroys so many things. So we always hear about, oh no, the ozone. Well, you know what? The ozone is a very bad thing right now because we have done so much of it that there's even more in our atmosphere than should be there. It's harmful and it's beneficial because we need some of ozone in our atmosphere because the ozone is actually what protects the Earth from receiving excessive UV radiation from the sun. But if you have too much of it in the atmosphere, then you can create what's called the greenhouse effect, which is basically the light is bouncing around and not leaving our atmosphere. So there's good, there's bad, and then there's also ugly, which is if you get too much hydrogen peroxide on your skin or too much bleach, you can cause harm. So there's lots of stuff happening that is good and bad. And here's the chemical reaction for ozone, where you have oxygen producing these free radical oxygens, and then these individual oxygens react with O2 gas to produce O3, which is ozone. Alright, here is a neat reaction that is a reduction reaction that you might have seen in your life. I used to really enjoy in my college days doing black and white photography. I thought it was just so much fun. Go into the dark room, and basically it was chemistry, but it was in a dark room, and it was fun. And so what's happening there is a chemical reaction where you've got silver bromide that's in the film and it's getting exposed to light. When that happens, the silver bromide is breaking down and turning into silver ions. Then when you take the film and you develop it, whichever silver ions were exposed to light can now be reduced to silver solid. And that silver solid is the black silver metal that you see in a photographic negative. So pretty cool. Yay, chemistry. It's what makes photography happen. And then you've got words such as catalyst. Catalysts are super important, especially to green chemistry. A catalyst is anything that can be used to speed up or lower the activation energy of a reaction. What I mean by that is the catalyst somehow makes the reaction proceed with either less energy being required or it makes the reactants combine more often. It's something like that, but the catalyst is never used up in the reaction, and so it's very sustainable reaction. Additionally, you might potentially have milder reaction conditions, such as a lower pressure or a lower temperature requirement, or maybe you don't need as much acid or base or something, so it could potentially be safer. So all of these things build into the fact that catalysts are an important part of green chemistry, and sometimes they aid the redox reactions just like they do for every other type of chemistry. Alright, then last but not least, we have photosynthesis. We've all heard of photosynthesis, but you maybe never thought about it from the terms of a redox reaction, where if we were to go and assign oxidation numbers to every single element on here, we would see that carbon is reduced, or at the same time, our oxygen is oxidized. And so you could say that carbon dioxide is reduced while water is oxidized. Either way, this is definitely a redox reaction, and this is one of the most important reactions that keeps and allows life to be sustained on Earth. So with this section of the textbook, you're just able to look at example after example of it, or example of really neat chemistry that all takes place because these electrons are moving from one species to the next, a redox reaction. All right, with that, that is the end of Chapter 8. So go complete all of your homework for Chapter 8, then take exam number 5, and then do not forget to complete your last assignment on the disappearing spoon.